breakout session on the bioinformatics and databases. I was trying my best to take notes on what have been discussed. So basically, we have discussed on four major topics. One is data sharing, deposition, and standardization. So a lot of questions have been raised. We reached some consensus, but still many open questions. For example, we talked about whether there should be one global DCP for HCA or multiple local consortium data centers. And there are pros and cons for each solution. And many of us have suggested we should have controlled access to the data in DCP for the data under development. And some funding agencies and regional regulations that can have restrictions on data sharing. So we should be aware of that, and also some ethics issues. So some possible solution we proposed is that maybe we can set up multiple instances of the DCP in some local regions so that the data are deposited in the kind of same standard, but maybe physically at different venues, different sites during the development. And also there are maybe other optional solutions following the same standard. So those are pretty much the, and of course, important thing is metadata should be standardized across different centers if we do have multiple data centers. And we also talked, the second topic we talked about our data visualization, especially data presentation to collaborators. There are some nice software we have seen, but surprisingly or not surprisingly, there are not much users yet. And some local consortium may have their own platforms to present their data with biological collaborators. And many people are using Jupyter notebooks, and some labs have their own in-house solutions, which seems to be efficient, and maybe some other labs can borrow them. And we learned that there is a UCSC cell browser under development, and hopefully it can be connected with the genome browser, so that so if that comes to be true, then maybe that can be a very effective way to work with data. And some of us raised this interesting question, that is, can CDI provide some server to host applications on the data, because that's sometimes very demanding. And those are the second topic. And the third topic we have discussed a lot of is about annotation. So there are several solutions for annotation, either software in the market, or there are many in-house solutions, and many labs have their own know-how in how to make the annotation. So there is a need for some community guideline. So we observe that the annotation is quite inconsistent across publications. And there is a strong need for a controlled vocabulary and a structured ontology on the annotations. And many of us raised the question about the need for some benchmarking data sets that we may have the ground truth, so that we can compare methods and as a reference for developing methods. But some also pointed out that this is really hard, if possible, especially considering the rare and unknown cell types. So this is open. And some of us suggested a practical solution that we think is probably very reasonable for the current phase. That is, before we can have a controlled annotation, we should make great efforts to do trackable annotation, that is to archive or present as much as information as possible in the metadata, so that all the annotation, how you came to the annotation can be tracked. So that's on the annotation. And then we talked about a more future topic that has not been mentioned in many of the previous discussions. That is, probably we need to have a more manageable representation of the cells. The question is raised like this. So it can be predicted that the information about cells, cell types, and cell states will be more and more rich. Rich is a good word, and the bad word maybe they tend to be more and more messed up in some way. So this is probably we need to we need some manageable ways to represent, to better represent them from the informatics side. So the cell types, and also some of us pointed out that currently people talk a lot mostly on cell types, but actually in many scenarios that cell type composition may be more important in many studies. And so there are two types of general tasks, that one is the differential expression analysis and the other is differential composition analysis. The later may be more important in the future, but there are also technical challenges, especially in the current experimental protocols, that many of the experimental protocols depends on some cell sorting, so maybe that can destroy the composition information. And in a way, we need some innovation, some new way in how to better present the cells in a more interpretable way. And some of us suggest that we should try to use the Facebook-like analysis and visualization of cell-cell relations and their interactions. Actually, there are some ongoing work in this direction, but visualization probably is a challenge. And we agree that annotating cell types, which seems to be the endpoint of many of current studies, but it should be the beginning of the cell atlas work is rather than the end. So I think, hope I have captured most of the information. So you have something to add? Thank you.
Cell types, we usually use the sorting data or just the protein level cell type annotation, right? But so when you make the annotation, we usually use the protein level annotating cell types, right? But I think when we told the known truth, that is just based on the already imputating, I mean.
I think that's an important question, but we didn't discuss that aspect of the question. We focused on the strategies of annotation, how to make annotations from different labs comparable rather than the annotation technique itself. I think that.
So we talked a little bit about ground truth, and one was lineage, perhaps using lineage trace mice, but actually I talked to Jani afterwards. What about index sorted populations? So you could actually sort based on protein markers and then profile, and then you have defined populations that you'd look at. Now, there's the biases of the actual index sort, but it's better than nothing.